all our fethu sanibonani molweni dumelang absheni loshani. This is another great edition of Your Learn Extra Live with me, AB, and I'm not alone, of course. I am having a woman. I'm with a woman next to my side because it's still a Women's Month. Dumela, oh, Dina, how are you?
Kiteng wena okay?
Lena kiteng, what's a kitawela one?
I'm sharp.
Lena, I'm sharp. Retang today.
What's on today? We're going to be carrying on with solving triangles this time round. Remember last week we did sine and cos rules. We're going to use some of those rules, but we're also going to look at how to calculate the area of a triangle that doesn't have a perpendicular height in it.
All right, Kelly. All right, my sisters, I have to tell you something good is that something that I said earlier on, that nothing is impossible. If Dina can speak Sotho like this, I mean, you can also speak another language fluently as she is. But otherwise, we're having something that we need to tell you. One, you can interact with us over Facebook, like our page, tell your friends about our page, post your questions on our page, and also help other main setters on the page. Our link is facebook.com/learnextra. Secondly, you can follow us on Twitter at Learn Extra. And lastly, you can download your notes all for free on learnextra.co.za/live. They're all for free. I'll also post the link on our Facebook page. But for now, let's continue, Dina.
Thanks, AB. Right, time to get going with the trigonometry. As I said earlier, we're going to be solving triangles by looking specifically today at the area rule and how to incorporate the cos and sine rules into it as well. So in today's lesson, we're going to use the area rule to calculate the area in a triangle. We're going to solve triangles by using the sine rule. For those of you who haven't yet seen the sine rule, it can be written as ratios of the sides of the sides of the triangle to the sine of the angle of that triangle. And if you've got an unknown angle, you'll have the angle in the numerator. And if you have the unknown side, you'll have the unknown side in the numerator. We're also going to use the cosine rule, which simply stated is really almost a little Pythagorean, where the side will be opposite the angle, and then you've got the sum of the other two sides squared and the product of those sides times the cos of A. So there are three squares, and there's also an angle involved in the cos rule. So we're going to have a look at that as well. But we really do want to look at the key concept for today's lesson, which is the area rule. And before grade 11, when you had to work out the area of a triangle, you would always say that it's your altitude multiplied by your base, and then you take half of that. And that was really the standard rule for the area of a triangle. So you really do need that triangle's altitude. Without an altitude, you can't calculate the area. Well, this area rule actually frees us to be able to work out the area without that altitude, which is really great when sometimes we haven't got an altitude to work with. And the way that the area rule works is it's got the sine of an angle that whose position, the position of that angle, is going to be between the two sides. So there are going to be some specifications on how to calculate the area, and that is that the information must be given in a side angle side format. So we need to have two sides, but we need to have the included angle in order to work out the area. So without that information, we also can't work out the area. It must be given as the included angle with two sides. So here you'll see that if I have B, then the opposite sides, and then the two sides that I'm referring to are AC. And if I have angle A, then the two sides I'm referring to are BC. So if we had to do a quick sketch of a triangle ABC, remember the opposite sides are the little letters A, B, and C. So if we looked at the first one, if I was taking angle C, then I must be given the other two sides that are sandwiching this angle, and it would be AB, hence AB. If I took angle B, or this is actually colored in yellow, there we go, then the two sides I'm referring to is AC, and if I took A, then the two sides that are sandwiching that angle are C and B. So there it is. So that is really in a nutshell the formula for the area rule. And we're going to try and look at a couple of diagrams and utilize that rule. Now, grade 11s, you must remember that there are 3 formulae around solving of triangles. There's your sine rule, which works with sine of ratios. That's why it's called the sine rule. The cosine rule, which has lengths, and then it's got the cos of an angle. And then the area rule, but there's no trig ratio called area. So the area is calculated by also using a sine ratio. Remember, if you're going to change it and make it a cos ratio, you're going to get the wrong value. So it's very important to adjust that the area rule involves the sine of an angle. Right, let's have a look at some of the examples. We want to be able to calculate the area of the following shapes. Firstly, in this isosceles triangle, and we've got PQ equals QR. So the given information is I have PQ equals QR. It's been marked on my figure. And so therefore this must be 6 centimeters. And we said that to work out the area, I need to be given side, angle, side, where the angle is included. So when I look at my picture, I've got this angle, I've got this side, but I haven't got the length of the side. And I can't work out the length of the side because to work out using the cos rule, or to use the sine rule, I haven't got angle P. So I'm a bit stuck. I've got a lack of information. So there must be another way of being able to get an included angle. And if you look at the 2 given sides of an isosceles triangle, this point here is actually called the apex. And this apex is where the 2 equal sides meet. I'm going to just look at this angle of 48. It's opposite 6 centimeters. And I know that in an isosceles triangle, if I had to fold along the perpendicular, because these 2 sides are equal, this would actually fold on perfectly. And so this angle would fold as the same value. So that is 48 degrees. Therefore, by having 2 angles of the triangle, I can actually find the 3rd angle. And through a quick, we have a 48 and 48 is 96, and we take it away from 180 because the angle sum in a triangle is 180. So that angle is actually 84. So we've got this angle as 84. And now we have side, angle, side. Okay, notice how we were missing that angle, so we'll have to go and calculate it, or we'll have to find an alternative. And it was actually impossible to find out QR. Now we can go and find QR, because with an angle, the side is opposite the angle, and that side's opposite that angle, so we can use the sine rule to denote that. So writing it up as a solution, we would have, always start writing the angle you found. So angle R would be the same as angle Q, which is 48 degrees. And that is because we've got an isosceles triangle, so we've got equal angles will be formed opposite equal sides, but this will only happen in an isosceles triangle. Okay? Then we have that angle P would be 180 minus the sum of R and Q, and give a reason for that, because our interior angle sum in triangle. And so that substitution of our 96 would give us angle P of 84. Okay, now we're ready to work out the area. So the area of the triangle is a half. Let's just go and look at the sides. So it would be PQPR, the 2 sides that are times the sine of angle P, that are adjacent to that angle, so it's included, and the sides were 6 times 6. Notice how I'm using brackets and not a dot. A dot in your final exam, you can overlook it because your mind looks so quickly at these things. and then we're going to times it by the sine of 84. Just to go back and see, do we have some units? Yes, we've got some units, so we're going to have our area in squared units. And we're going to have a 36, a half of that, so it's an 18 multiplied by the sine of 84. And we've got that as 17,9. And remember, it's squared units because it's area, so it's squared centimeters. Okay, right, so a nice example to start us off. Let's go on to the next one. Calculate the area of the following shape, the equilateral triangle TRY, or tri. Okay, so again, working with area, we would like to get a side angle side, otherwise we can't get the area. Included angle between the two given sides. And what is special about an equilateral triangle? Grade 11s, do you know what's special about an equilateral triangle? Right, it's a special triangle. It's unique, it's one of a kind, where all three sides are equal. So all these angles will be the same size, but because three are the same size in 180 degrees, it must mean that each one then is 60 degrees. So we've got 60 degrees. And so coming back and filling that information here means that each angle is 60. And if one length is 4, then all lengths are 4 centimeters. And now the SAS is easy because we sandwiched between 4 and 4 with a sine 60. Okay, so writing up the sine rule, or not the sine rule, but the area rule. The area of triangle TRY will be a half of TR times TY times sine 60. And so that would be equal to a half of each side times the included angle. And let's see what our calculator gives us. 8 times 4 fours is 16, half of 16 is 8, times sine of 60. And that gives us 4 root 3, which is 6,93. 6,93. And that was also centimeters. So we're going to have squared centimeters. Okay, so we've got a very useful formula when the triangle doesn't have an altitude. In both the isosceles and the equilateral triangle, we did not have an altitude, yet we could work out its area. Remember, we are confined to a specific formula. It's not just any sides and any angles. It has to be the position of the angle has got to be between the two given sides. So I often say the angle's got to be sandwiched between the two sides. In other words, the angle's got to have adjacent sides to it. And then it's as easy as anything to just substitute into the formula half of the two sides, or the product of the two sides, multiplied by the sine of that included angle. And I think on that note, we'll take it back to AB.
Thank you so much. You know, the show is just about me today. I saw on one of your diagrams there, I'm there, AB.
Oh,
so
you're very popular, AB.
But anyway, here's what a mindset I had to say on our Facebook page by the name of Sovomakamu Kamza. You're going to like this one. She says, exams are near, subjects are not clear, questions appear, answers disappear. Oh my dear, don't fear, because I'm here to wish you all clear. Have a great exam first. So thank you very much, Msovo, for that. So inspiring and very poetic, so it rhymes. So thank you very much for that. Mindset is, be sure to download your notes that are proudly sponsored by Macmillan on our learnextra.co.za/live page. See you after the break. Welcome back, pre-matriculants. Now it is also that time where I remind you that you can chat to me, ask some questions that you want, and also help other mindsetters that are struggling on our Facebook page. Our link is facebook.com/learnextra. Let's learn more and learn extra. Dina?
I'm interested. AB's calling you all pre-matric. I wonder if we should change that in our schools and let all the grade pre-matrics please come to the hall or something like that.
I'll ask the mindsetters, what do they think of that?
And then when they go to first university, they'll be called post-matric.
Very
Thanks, AB, for
creative.
that. Right, grade 11s, we are working with the area rule. We've worked with some shapes. We've worked with an isosceles triangle, an equilateral triangle, and I'd like to look at a couple more shapes in terms of finding the areas where no altitude has been given. Let's get to it. Right, so we've got a parallelogram, and so that AB doesn't think is so important, I'm going to start with calling it CDBA. And the parallelogram has got its measurements. It's got a BA as 5, it's got BC as 4, and it's got angle A as 120. And we need to work out the area of that parallelogram. Now, what do you know about the properties of a parallelogram? It's a beautiful shape where it's got opposite sides parallel, but it's got many other features as well. It's got the opposite sides are also equal in length. So we've got this length is equal to that length of 5 centimeters. And we've got that length is equal to that length, which is 4 centimeters. Remember, pre-matric students, this is all from grade 10, so pre-matric students, right? And we now would like to work out what the area is if we have this shape here. If I outline this triangle here, can you see we've got just the right information? We've got angle, we've got side and side. So the two sides are sandwiching that angle. And we would like to work out that area. Now, what would happen when we come to this triangle? What do we know about the diagonal of a parallelogram? It actually divides, the two triangles are congruent. If we just reflect, we rotate, we will find that this shape falls onto that one. So we can actually double that yellow area. Or, what do we know about the opposite angles of a parallelogram? They are equal. So we would actually also get SAS, which is exactly the same sides. Okay, so writing that up, we would get the area of triangle DBA is equal to a half of AD multiplied by BA multiplied by the sine of A. Substituting the lengths, we've got 4 by 5 multiplied by the sine of 120. And then our calculator can actually work that out as a half of 20 is 10, so it would be 10, no, we want 10 times the sine of 120. So we get 5√3 or 8,66. Again, it's in centimeters, so the area will be 8,66 squared centimeters. Now, that would be the area of the yellow. Okay, but we actually want the area of the whole parallelogram. So the area of the palm would be the area of the triangle times 2, because the diagonal bisects the area of the parallelogram. And so that would just be a double of this value, and we'd get 17,32. So 17,32 squared centimeters. Okay, right, lovely, nice and easy to work with a parallelogram. Our next shape is a rhombus. And what's special about a rhombus? What can you remember about these kinds of quadrilaterals that have got special properties? If you had to imagine sitting, or if you had to imagine a square made of just wire, and if you had to sit on that wire, that whole shape would change. And that is really what a rhombus is. It's kind of a squashed square, if you want to call it that. So it's got all 4 sides equal, but they're not at perpendicular to each other. They're sitting at opposite angles. And so they've got all the properties of the parallelogram, but the special property that the adjacent sides are also equal, so therefore all four sides are equal. So it's important to recognize these properties, because when you are putting information in onto the shapes, you'll be able to fill in angles, you'll be able to fill in sides, that kind of thing. So it's good to always just keep check on those special quads and what kind of properties they have. Okay, so we also want the area of the rhombus, and we've just said that the rhombus is a parallelogram with all four sides equal. Now, if somebody had to tell you that, but you didn't decode it into this, you wouldn't be able to have any information on this figure. You wouldn't be able to add anything else on. So can you see how important it is to establish what are the unique properties of that figure? Okay, so I'm first of all going to take a diagonal and divide it, because I can only find area of shapes. We've got area of triangles. And then we've got that the rhombus has got all four sides equal. Okay? And when setting out your calculation, you must first stipulate that the RH is equal to RM is equal to 5 centimeters adjacent sides of rhombus. So there's a reason why you're marking off those. They just didn't appear from space, and they just exist like that. There's a reason why they exist. And then we're going to work out the area of triangle RHM. Let's remind ourselves what is key. We need to have the given information needs to be SAS, two sides, and an included angle. So we have the two sides are RM. Actually, we need a little bit of a half of RM multiplied by RH multiplied by the sine of the included angle, which is R. So substituting in a half, each side is 5, and it's the sine of 55 degrees. Right, to our rescue, use our little Casio, and it would like to multiply 25 by a half, and then also multiply it by the sine of 55 degrees to give us 10,24. Notice I'm rounding off to 2 because the matric exam often asks you to round that off to 2 decimal places. So it's 10,24 squared centimeters. However, that is the area of the rectangle, of the triangle. The question was, determine the area of the rhombus. So to work out the area of the rhombus, again, the area of the rhombus, there are two such triangles, so it's 10,24 doubled, and the reason is because the diagonal of rhombus bisects the area, bisects the area, or bisect its area. So doubling that would give us 20,48. 20,48. Don't forget units. We were working in centimeters, so that will be centimeters squared. And hence again, we did not have altitudes. We didn't need altitudes. We can work with our area rule to work with the sides of our figures. And the beauty about quadrilaterals is most quadrilaterals will have opposite sides equal, but then you'll get a shape where it has all four sides equal. The square and the rhombus are a case in point. So that was quite easy to work out as well. Okay.
Before you move on, Tina,
Yes.
I have a couple of questions for you.
Yes.
The first one is from one Alice Mpiwe. Anila says, please ask Ma'am Dina, how does she derive the formula for each question for the area rule?
How do we derive the
the
formula?
formula for each question for the area rule.
Okay, let's have a look at that. I'm going to try and answer this question, trying to understand what she doesn't get or what clarity she needs. And I've actually written down, for example, let's look at the previous example, the yellow triangle. We were working with the area of triangle DAB. Where do I derive this formula from? The formula is standard. It's always going to be half of the product of the two sides multiplied by the sine of the angle. And like I've done with the sine rule and cos rule, I have not proved them here in the studio. I'm leaving that for your teacher, because your teacher will prove that with you, and you'll be required to know the proofs for examinations. That's a very good question, how you actually get the proof. But if you're looking at a specific diagram, then you need to look at the two sides that you're working with that are adjacent to the given angle. And that's where I get the formula from. It's always the same. It's the included angle. So if we were to, for example, look at this triangle and call that KLM, then the side opposite the angle is little k, little l, and little m. And if I chose an angle, I'm going to choose completely arbitrary angle, I'm choosing K, then the formula for the area of the triangle KML is going to be half of the two sides that you're working with, which are adjacent, so it's that side, and we're going to then multiply it by the sine of K. So two sides adjacent with the included angle. And it's always standard. That's its formula. What I'm not doing is I'm not showing you the proof. Hopefully that answers the question.
Well, still on that one,
Yes.
you know, linking it with the previous question,
Yes.
how, Londa says, how do you see when to use the sine rule or the cos rule? E.g., area rule, we must have the SAS.
Yes. So is she trying to say, when do you use the sine? Okay, so I've showed them that the area rule, you need an SAS, a given information of SAS. What about the sine rule? What about the cos rule? Okay, that's a very good question. Let's carry on this diagram here. When do we use, what, in other words, what information must I have to use a sine rule? Okay, sine rule. And this is going to happen when information is opposite each other. So I haven't got a simple thing like the area rule, but the information must be opposite each other. So if I give you a triangle, and let's just erase that. So if we go there, and if I have a triangle, TPU, then to use the sine rule, if I have angle T, I must have the side opposite angle T. So the best way is just with colors. So my angle and side is opposite each other. And if I have angle P, then I should be looking for the side opposite that. So I crisscross. Angle, side, angle, side. The info, whether you're finding it or whether you're given it, has to be opposite each other. Otherwise, I'm not going to be able to find the sine rule. I'm not going to be able to use the sine rule. Okay? And then the next one, and grade 11, this is a really good question. When do we use the cosine rule? Again, if I have any triangle, A, B, C, then the sine rule is used in two occasions. One, if I've got the three sides, SSS, I can find one angle. And two, also like the area rule, if I have SAS, I can find the side, the last side. Okay, so we have two conditions for the cos rule. If I have three sides, I can find one angle, and if I have side angle side, I can find one side. And that's basically the 4 criteria for solving triangles.
All right, thank you
Nice
very
question.
much. On that note, I think we should take a break. As Fumani says, I live maths, I dream maths, I eat maths, and I love maths. So it's time to drink maths now, Fumani, and see you after the break, Mindsetters. Well, the poll on the page says that yes, most of the mindsetters would love to be called pre-matriculants, and few of them are saying no. And actually, Dina, what I find surprising is that most of these mindsetters, well, not most, some of these mindsetters have failed the question, because I said you should answer yes or no, but some are saying nah, yeah, yeah. So you should be careful when you're given an instruction, follow that. Otherwise, back to you, Dina.
Very good advice, Prematrix. Very good advice. It's yes or no.
Not yeah, nah.
Right, grade 11s, we ready to carry on with another set of examples that's really going to use what the mindset just before the break asked, which was how or when do I know to use the sine rule and the cos rule. And so we went through that over the break, and we're now going to put that into practice, because we're going to get a question which is going to demand that we look at when do we use both of those rules. So just to go over it again, if you're going to use the sine rule, you must find your information opposite each other. So yellow angle, opposite yellow side, pink angle, opposite pink side, and if that information is not opposite each other, then I can't work anything out. So if I had, for example, this, and then I had this angle and this white side, this is not a opposite information. So I wouldn't be able to use the sine rule. What I could work then, because I've got side, angle, side, is I could then use the cos rule. Because if you look at the cos rule, when do we use the cos rule? You can use it whenever you have side, side, side. So if I have all three sides, you can pick an angle. You are not forced to work with any angle. You can pick an angle. I could find angle B, and once I've done that one, I could find angle C, and once I've done that one, I could find angle D. So we could find angle A. So we could find all three angles as long as we've got side, side, side. However, if we have side, angle, side, yes, we can find the area, but we can also find this length B. So we have the opposite side to the angle is what we can calculate. So if we've got SAS, we can find the third side, and if we have side, 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 we can decide which of these angles we can calculate. It's up to you, and it depends on the question. Okay, having gone through that beautiful revision that the mindset asked us earlier, let's see what's in store in question 2. Trap is a trapezium with TR parallel to PA, and if I glance down here, there's TR, there's PA, and the two lines are parallel, and they've marked it on the diagram. We need to calculate the length of PR. So let's go and see what's happening here. So we've got TR is parallel to that length there, and we would like to work out the length of PR. So how long is this length over here? Okay, mindsetters, you tell me, where should we go from here? We would like to find this length. It's obvious we don't have information in that triangle, so we're going to concentrate on this triangle over here. We have this length, we have this angle, we have this length, and the unknown length is this purple length here. So can somebody shout, can I hear you from your couch, which rule do we use when it's side, angle, side? It is indeed the cos rule. Well done, the cosine rule. So the cosine rule is quite a long one, and you need to kind of memorize it. You need to remember that one's got quite a lot of squares in it as well. And it basically says that the side that you need, so we're going to start with PR squared. PR squared is going to equal 2. The other 2 that you know, so it's TR squared plus TP squared, and then you're going to minus 2TR TP cos of T. So the two sides that you know squared, and then cos of t is the included angle. So you'll see that that side is actually opposite the known angle. Once you've got that, you can then just substitute in. So I'm going to do the substitution over here. We're running out of space there. So PR squared is equal to 10 squared plus 6 squared minus 2 times the 10 times the 6. While you're writing it down, you're making sure that they're the same, times cos of 116. Once we've got those values, we can now go on to our calculator. It's 10 squared and 6 squared. So it's 100 plus 36 minus 2 of that. So it's a 60, and it is a sine, no, it is a cos of 116. So we get 188,6. But remember, that's PR squared. So we need to take the square root of that answer. And we get 13,73. 13,73, and its measurements are in centimeters. Okay, so nice use of the cosine rule by being given side angle side. So that's PR, the length of PR. Now, we need to work out the size of TRP. So TRP is this angle over here. I'm going to call it 1 and 2. We want to find the size of that angle. Okay, so now the first thing is you always work with the sine rule if possible, because it's so much easier. There's my angle that I need to find. There's the side opposite that. Okay, there's my angle that I have been given, and I've just worked out that that is 13,73. So I do have information that is opposite each other. So I'm going to use the sine rule for that. You could, if you wanted to, use the cos rule, because you've got 3 sides, so you could use the cos rule. However, the cos rule's got a lot of algebra in it. It's got squaring, it's got addition, it's got multiplication, it's got subtraction. So I try and avoid it, if possible, because it's so complex. I would rather use the ratio. I would rather use the sine rule. Okay, much simpler to work with ratios than it is with the algebra. So the question that, well, let's first just write up here. We want to find R1. So your sine rule would say that sine of R1 over the side opposite that, which is over 6, would be equal to the sine of 116, and which would be opposite that, which would be our 13,73. Okay. Now, grade 11 is just a note on rounding. Yes, in your book, you might write it in a rounded off form, but when you are working with your calculator, you need to keep all your decimals in there. Otherwise, rounding error is going to compound, and at some stage, you're going to really be coming short with all these rounding offs. So that is our value there. I think we still have 13,7 on our calculator. There we go. So let's just come here, and we need to get the reciprocal of that. So if we take that to the minus 1, that means I've got 1 over that, multiplied by the sine of 116. So that's what's on the side, and then I'm going to multiply that by 6. So I get a ratio of 0,39. That is what sine R1 is equal to. So sine of R1 is equal to 0,39. How do I find R1? Is we're going to find nothing. We're not going to find that. Okay. Okay, we've lost that value. Let's just do that again. So we had 100 plus 36 minus 2 times 60 times the cos of 116. We had that. We had the square root of that. Okay. And then we had the reciprocal. We had times sine of 116. And we had times 6. Okay, and now we want to find, shift, there we go, the angle that gives us that sine. And that is an angle of 23,12 degrees. So 23,12 comma 1, 2 degrees. That's R1. Okay. Then the size of RPA. RPA, that's 1, that's 2, and RPA would be angle P2, this angle over here. I'm sure you know lots about the properties of parallel lines, so we've just worked out that that's 23, comma 1, 2. So the angle that would be over here would be 23, comma 1, 2. Those are alternate angles. Okay. And now the last question is calculate the area of the trapezium. Okay. So now the area of the trapezium is not bisected by that diagonal. I can see that this triangle's area is not the same as that one. But we can work out what the area of that triangle is, and we can work out what the area of this triangle is. We've got enough information. Remember SAS? So it's 10 times 6 times the sine of that angle, and then we would like these two. This one's been given as 15. This one we've worked out earlier as 13,73. And then we've got the sine of 23,12. So we can actually go onto our calculator and put all that in. Actually, before doing that, let's just write that up. Let's go down. So we're going to have the area of the trapezium will equal to the 10 times the 6 times the sine of 116 plus the half of the 13,73 by the 15 multiplied by the sine of 23,12 degrees. And that's really what we need to get onto the calculator. I wonder if they make this Casio just a little bit smaller so we can fit it in here. Right, so that's 60 times a half, so that's 30, multiplied by sine of 116. And we want to add 0.5 times a 13.73 times by a 15 times by the sine of 23.12. And we get 67,4. 67,4 squared centimeters. Isn't that wonderful? A trapezium without altitudes. We've been able to work out its area by just having some of the information and being able to work out the other sides by using the cos and the sine rule. Absolutely fantastic. Any questions, AB?
Oh yes, I have a question for you.
Yeah?
Which may not be about that question though.
Yes.
From Quentin. Quentin says, would it ever happen whereby you're only given an angle side to calculate area of a triangle?
Quentin, that's a tough question to answer because it really depends what else you are given. Remember, just go back to our notes from the start of the show, we were given an isosceles triangle very much like that. So just to extend here onto Quentin's question, would be if I have an isosceles triangle with what he's saying, one side and one angle, then yes, I can still use the area rule because I can calculate this angle and I can calculate the apex angle and I can find that 6. I can still work out the area. So it really depends what else you're given with that information. So if I was given an isosceles triangle with Quentin's information, yes, I can still find the area rule. However, if all I was given was a triangle with a side of 6 and an angle of 48 and nothing else, so if I was given that triangle as a scalene triangle, then guess what? I'm stuck. I haven't got a third side. So yes, I can't find the area then. I would have to go and create or measure and find a number of triangles that would have that information on it. So it really does depend what extra information is given you. Okay.
All right.
All right, and then one last question. Grade 11s, I want to take we've been calling you pre-matrics today, so let's take you into a grade 12 exam, and just so that you can see how that question appears in your paper 2 of a grade 12 examination. I have adapted this question from the March 2011 paper. So we are given a sketch which shows one side of the elevation of a house, and some dimensions in meters are given. We need to pay attention to the units. On the figure, calculate rounded off to 1. So 2 things we need to pay attention to: the units that we're given and how many decimal places we need to round off to. And we would like to find EC. So let's go to the picture. We'd like to find the length of EC, and we've been given that DE 7,5, and we've been told that that's in meters. We've been given this angle, and we've been given that this is 3,5 meters. So we've got a 3.5 meters, 7.5 meters, and this is a side or a cross-section of a house, and we'd like to be able to work out what that dimension EC is. Okay? Now, I think using what we've just said earlier, we need to find out, maybe before even finding EC, we need to work out how long is this length over here. Because if this is a rectangle, then I'm working with this as 3,5, and this is 3,5. And I really don't have much to go by because, okay, well, let's see. We've got this yellow information. This EC is opposite the 32. And we've also got that this blue is opposite this blue angle. So we could work this angle out. And once we've got the angle, we can then work with the sine rule. But that's actually not enough information because there's my unknown, and this angle here is also unknown. So let's just see if anything else is given. Okay. I think we may be missing the length of AB, because if we had AB's length, then that would be a rectangle that would have this length as well. Would be the same as this length. And in that case, then we'd have side, angle, side, and we could find out that using the cos rule. So I'm going to propose that we need to go and Google this question, and we need to go and find how much was that length in the exam paper, or then we're just going to assume that this length here is possibly 8 or 9 meters to be able to work out what EC is. And once we've got EC, then DCE, then it will be possible to work out this angle by using our sine rule. And once we've got that, we can then find the area of triangle DEC, which is trying to find that angle there, so that then you can work out what this area is. I'm still trying to see that this length here can be calculated by using the right angle triangle, so we can find that height, the total, well, we can find that height, but we just don't know what that length is. So I'm proposing that we need to find out how big this is, otherwise this arrow wouldn't be here. So we'll leave that one as unfinished, so that grade 11, you've got some work to go and do on that grade 12 problem.
We'll post it on the page, actually.
We'll post it on the page, yeah.
Right. Thank you so much, Dina, and thanks to you all Mindsetters for tuning in. Remember, if you still need some help, go to mindset.co.za/learn/help desk and send us all those questions. And also a big thank you to Macmillan, our proud sponsor, for the notes that we're having all for free. Otherwise, just know that nothing is impossible to a willing heart. We love you and peace.